Hello everyone, my name is Taehyung. Today, I'm excited to present our research, Externalizing social cognitive structures for user modeling, through theory-driven profiling with LLMs. This work was working with Seungwan, Haein, and Professor Kyungsik. Let's begin with our motivation. Why is deeper user understanding so important? Current user model based on LLMs have a limitation. They mainly focus on surface-level preference like keywords or simple likes and dislikes. This approach can predict what a user might do, but it fails to explain why they do it. It also struggles to predict how our user interest might change over time. Human behavior is complex. It's influenced by hidden or latent factor, psychological, social, and contextual. We believe that capturing this latent factor is crucial for building truly personalized and dynamic systems. So, how can we model these latent factors? Our solution is to ground our user model in psychological theory. We adopted the theory of planned behavior, which is called TPB. TPB is a foundational theory that explains behavior through three core components. First, attitude. This is a person's positive or negative feeling about the behavior. For example, I think buying banana is a good idea. Second, subjective norms. This is the perceived social pressure. For instance, my friend think I should buy them. And third, perceived behavior control. This refers to the perceived ease or difficulty of the behavior. For example, I can easily find and uphold them. Our core idea is to leverage an LLM's reasoning capabilities to automatically extract and structure these three components from user text. Based on this idea, we developed our framework, which is called Triple. Triple stands for TPB-driven profiling with LLM refinement. It works in three main steps. First, TPB-based profile generation. We extract the initial TPB components from the user's historical data to create a profile. Behavior prediction and profile refinement. Next, we use this profile to predict our user behavior. We then compare our prediction with the actual behavior. If there's an error, we use it to refine and improve the profile. This is an iterative cycle. Finally, dynamic profile update. The refined profile from one time step become a starting point for the next time. This allows the profile to adapt a new data and evolve over time. To evaluate our framework, we designed an experiment. We use LLM benchmark because it provides temporal user histories, which is perfect for testing our dynamic approach. We tested our model on two tasks, rating prediction and personalized news headline generation. We compared Triple against two types of baseline, non-profiling method and surface-level profiling method like PAG, pure. To ensure our method is generalizable, we implemented Triple on several open-source LLMs such as Llama and Gemma. Now, let's look at our main purpose result. This table shows the result using the Llama 8 billion. The performance of other model can be found in the paper. First, if you look at Triple, no refined version, show that our initial TP-based approach is already competitive with other profiling methods. Next, the Triple refined version shows that our iterative refinement process consistently improves performance across all models. Finally, the complete Triple version achieves the highest performance. This indicates its effectiveness in handling evolving user data over time. Overall, Triple consistently outperforms existing methods. Let's dive deeper into the impact of profile refinement. This graph shows performance over 5 refinement iterations. On the left, RMSE goes down, which is better. On the right, Rouge L score goes up, which is better. As you can see, with each refinement step, the performance steadily improves for all models. This confirms that our predict evaluate refinement cycle is effective. It successfully corrects prediction errors and enhance the profile accuracy over time. We analyze the impact of our dynamic method. Here we compare our method consistently delivers strong and stable performance across all update sessions. In contrast, the sliding window method performance often degrades as it loses historical context. The poor regeneration method is unstable. This shows that Triple update method provides a balanced approach, adapting a new data while preserving long-term profile consistency. Our contribution can be summarized as follows. A novel theory-driven framework. we proposed a new framework that integrates social psychology theory into LLM-based user modeling. Competitive performance. We show that triple achieve excellent performance outperforming existing method on the RAM benchmark. Dynamic and explainable profiling. We introduced a method that not only captures evolving user states dynamically but also provides prediction grounded in a theoretical framework, making them more explainable. We believe our work shifts the paradigm of user modeling towards a deeper, theory-driven approach. Thank you, Barry, for your attention.